Hello and welcome to this Edexcel Further Math Statistics 1 video looking at finding the mean and variance using a generating function. So at the top of this slide we have the definition for a generating function, and if I just write that out in terms of the summation form, I would get t to the 0 multiplied by the probability x is 0 plus t to the 1 multiplied by the probability x is 1 plus t squared multiplied by the probability that x equals 2, and so on. And by all means write a few more of these out yourself. Now we're going to consider what happens when we differentiate the generating function with respect to our dummy variable t. So I think you can see that if we differentiate t to the 0, t to the 0 is 1, we're going to get 0. And for the second term in this expression, if we differentiate t to the 1, we're just going to get 1. And t squared, we'd get 2t multiplied by the probability that x equals 2. And as I say, do try a few more terms yourself. So how might this help us find a mean? So here we have a slightly neater version of the generating function, first derivative on this line here, 0 multiplied by the probability of getting 0, 1 multiplied by the probability of getting 1, 2 multiplied by the probability of getting 2, t to the 1, 3 multiplied by the probability x equals 3, t squared, etc. And what then will happen if we let our dummy variable t equal 1? So that may sound like a strange thing to do, but t was just a variable we decided to use, so let's let it equal 1 in this particular case. So we're going to have no effect on our first two terms. The third term will just be 2 multiplied by the probability x equals 2, because t is just going to be 1, and our next term will simply be 3 multiplied by the probability x equals 3, because t squared will also equal 1 if t equals 1. And that should be an expression that you recognise. And indeed that first derivative of the generating function with t equals 1 gives us the sum of each outcome possible for x multiplied by the probability that x takes that value, and that's something you should recognise as the expected value of x, or the mean of x. So we can see that g-1, the first derivative of the generating function with t equals 1, gives us the expectation or the mean of a random variable x. So we have found an expression for g-t, the first derivative of the generating function. What happens when we differentiate that a second time? And what happens when we let t equal 1 in that expression? So if we differentiate a second time, the 0 will differentiate to 0. Probability x equals 1 is just a constant, so we differentiate that with respect to t and we get 0. The third term here would just be 2 multiplied by the probability x equals 2 multiplied by 1, because t to the 1 will differentiate to give us 1. And the fourth term there would be 3 multiplied by the probability that x takes the value 3 multiplied by, if we differentiate t squared, we get 2t. And again, do write a few more of those terms out yourself. So we obtained this line here on the previous page, and I have just written this out slightly differently. So rather than just saying 2 multiplied by the probability that x equals 2, to identify the pattern that's going on here, I've written that as 2 multiplied by 1. and rather than having 3 multiplied by the probability x equals 3 multiplied by 2t, I have put the 2 at the front there multiplying the 3, and the general term we get in this particular summation is this term here, and if you've written a few more out and differentiated yourself, you will see that pattern very clearly emerging. And if we then substitute t equals 1 in there, we are going to get the expression here, 2 multiplied by 1 multiplied by the probability x is 2, 3 multiplied by 2 multiplied by the probability that x equals 3, and so on. And our general term is x multiplied by x minus 1 multiplied by the probability our random variable takes the value x. So how can that be simplified to use to try and find a variance? So what we can do is take our general term and say what we have for the second derivative of the generating function, where t equals 1, is the sum over all the outcomes for x of the terms x minus 1 multiplied by the probability x takes the value x. And now we need to think from this expression here how we can simplify it to try and find an expression for a variance. And if we take the summation and simply multiply out, so x multiplied by x multiplied by 1, we would get sigma x squared minus x multiplied by px equals x. And because of the linear nature of summations, we can split that into one sum, which is x squared multiplied by the probability that x takes the value x, minus the summation of x multiplied by the probability that x takes the value x, and that you should recognize as ex squared minus the expected value for x. Remember that for any discrete random variable, this is the expression for the variance, and we have these two results here from differentiating the generating function once and twice and substituting t equals 1. We know that g-1 equals the expected value of x, and g'1, the second derivative with t equals 1, gives me ex squared minus ex, the mean. And from this second expression here, we can obtain the result that ex squared can be written as the second derivative of the generating function with t equals 1 plus the expected value of x, and that of course can be written in this form because we know that e of x is g-1. And so using what we know about the variance for a discrete random variable, we can simply substitute in ex squared minus the mean squared, and that's our expression for the variance of a discrete random variable x evaluated using the probability generating function. And those results for the mean and the variance in terms of the generating function are given in the formula book. So the results are summarised here, and you should make sure you're familiar and confident with the expression for ex and the expression for the variance in particular. So using these definitions, let's look at an example to find the mean and variance. So the first step probably would be to write out our generating function in terms of the sum of two expressions in terms of t, and that makes it nice and easy to differentiate once, which would give me 2/5 plus 9/5 t squared, and if I differentiate a second time, The 2/5 will differentiate and give me 0, and I will get 18 over 5t. And then simply substituting t equals 1 into the expression for the first derivative, I will get that g-1 is 2/5 plus 9/5, which is 11/5, and that then directly gives me the mean or the expected value of x. If I then take the second derivative and substitute 1 in for t, I will get 18 over 5. And using the expression above for the variance would then be 18 over 5 plus 11 over 5 minus 11 over 5 squared, and that would give me 29 over 5 minus 121 over 25, which is 24 over 25. And so by some very simple differentiation and substituting t equals 1, using the results at the top of this slide, we can find the mean and variance for that random variable x. And that concludes this video. We will next look at probability generating functions for some common distributions.